Hello again, Workplace 11. 1.2. We're going to do two things today. First of all, we're going to look at rates, and then we're going to use proportions. Remember we talked about proportions last lesson. We're going to use proportions to solve problems, including problems with rates. We're going to have problems with ratios and with rates. Okay, so what's a rate? A rate is a comparison of two numbers with different units. Wait a minute, this first part, a comparison of two numbers, that's what a ratio was, right? So basically what a rate is, it's a type of ratio, but it's a ratio that has, this is really important, different units. So last day when we talked about ratios, it always had the same units, right? When we were comparing like the number of ducks and the number of cows, those are all animals. So 3 to 2, you didn't have to put any units in there. But with a rate, there's different units involved. So for example, a car traveled 40 kilometers in 4 hours. You can see there's different units here. So if you were going to write the ratio, you couldn't just write like this, oh, it's 40 to 4. You can't do that because you're not talking about the same thing here. You need to include the units when you write a rate. You don't do that with a ratio. You don't write the units because they're the same. But with a rate, you have to write it. So you would write 40 kilometers in 4 hours, right? Or how do you usually write it? If you're talking about something like a rate, like kilometers, you often write it like this. Instead of writing the colon or the word to or as a fraction, you often write it like this, 40 kilometers slash 4 hours, right? 40 kilometers per 4 hours. Now, you might say to yourself, well, that doesn't sound right. 40 kilometers per 4 hours? We don't usually talk about per 4 hours. We're going to talk about that in a second when we talk about unit rate. So just 1 second. I'll give you one more example. Byron paid $15 for 5 chocolate bars. Again, we have different units. We have the chocolate bars and we have the dollars. So if you're going to write this as a rate, again, you'd have to include the dollars, you'd have to include the chocolate bars. You couldn't just put 15 to 5 like we did last day. You couldn't just go 15 to 5 and say, I'm done, that's my rate. No, that's a ratio, and this is not a ratio because it has different units in it. Alright, so again, it's kind of weird to be talking about $15 for 5 chocolate bars, right? If someone says, how expensive are the chocolate bars? You wouldn't say it's $15 for 5 chocolate bars. You'd want to know how much it costs for 1 chocolate bar, right? And same here, you wouldn't say, if someone said, how fast were you traveling? You wouldn't say, oh, I was going so fast, I was going 40 kilometers in 4 hours. You would tell them how far you went in 1 hour. Well, this gives us the idea of unit rate. A unit rate is a rate in which the second value is 1, right? The word unit refers to one of something. If you have a unit, you have one of it. So a unit rate is a rate in which the second value is 1. So I'm going to take a look at these same examples. So here's our 40 kilometers for 4 hours, just like I wrote up here. And here's our $15 for 5 chocolate bars. I didn't write it, but you can just see that's simple to write that rate. We're going to write it as a unit rate. So how do we do that? We want to turn this second number into a 1. Well, I'm not going to go into too much detail here, but I bet someone can figure this out. If you went 40 kilometers in 4 hours, then how far did you go in 1 hour? You get 10 kilometers in 1 hour. Again, that's one way you could write it. This is a rate, a unit rate, but how you usually write it is 10 kilometers per hour. And you don't even put the 1, right? 10 kilometers per hour. That means per 1 hour. Okay, similarly here, $15 for 5 chocolate bars. We don't want to know how much 5 chocolate bars are. We want to know how much does it cost for 1 chocolate bar. So if it's $15 for 5, how much does it cost for 1? It costs $3 for 1 chocolate bar. Or again, you could say $3 per, I'm just going to put bar, $3 per bar. Okay, these are unit rates when the second number is 1. We didn't even write the 1, but there's like a 1 here and a 1 there. I don't know why I used yellow, you can't see it. Alright, so now what we're going to do is we're going to solve some problems. Ooh, word problems. They're going to be ratio problems and rate problems. And even before I show you the problems, I'm going to give you the steps. 3 steps. It's actually kind of only 2. First thing you're going to do is you're going to write a proportion. Remember, a proportion is a statement that two ratios are equal to each other. And we're going to write them as fractions. Why are we going to write them as fractions? Because that's going to make it easy for our second step. We're going to solve using cross multiplying. Okay, we did lots of cross multiplying last time, so I'm hoping you remember how to do that. And then step number 3, not much of a step, just make sure you clearly state the answer. It's a shame to do all the work and then I'm not clear what your answer is. So make sure it's clear what you're saying the answer is. All right, here we go. On average, 33 centimeters of snow melts down to 2.5 centimeters of water. How many centimeters of water will 125 centimeters of snow melt down to? All right, well, everything here is talking about centimeters, right? We got centimeters, 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 so the units are all the same. This is a ratio. It actually doesn't matter. If you couldn't even tell if this was a ratio or rate, it really doesn't matter. But this is a ratio. So the first step, we want to write a proportion, two equal fractions, right? So we're going to have one fraction, we're going to say it's equal to another fraction. All right, let's look at what we know. We know that 33 centimeters of snow melts down to 2.5 centimeters of water. In other words, there's a ratio here. There's a comparison. There 33 centimeters of snow melts down to 2.5 centimeters of water. We don't need to write centimeters because the units are all the same. It's a ratio. If you want to put centimeters and centimeters, it's fine, but you don't have to. All right, we should have one other number. Do you see it? It is here. 125. So here's the part where everyone messes up. Well, not everyone, but here's the most common mess up spot. This 125 is going to go in the second fraction. Is it going to go on the top, like up there, or is it going to go on the bottom, down here? How do you tell? Well, here's what I strongly recommend you do. So many people are resistant to doing this, but it really doesn't take long. Just write down a word or even a letter that tells you what this 33 is referring to. It says, on average, 33 centimeters of snow. Oh, so the 33 is snow. Melts down to 2.5 centimeters of water. Oh, the 2.5 is water. Okay, this number here, the 125, is that a snow number or a water number? 125 centimeters of snow. So over here, where should I write it? Top or bottom? Well, since the snow number is on the top here, the snow number should also be in the top there. Our 125 goes right here. What goes down here? Well, that's what we're trying to figure out. That's the thing we don't know. When you set up these proportions, there's going to be 3 numbers you know and 1 you don't. So what can you put there? You can leave it blank. You could put a variable like m or n or whatever you want. W, because we're talking about water. Let's do that. I'll put W. You don't have to, but I'll just do that. W. Okay, so now we're going to solve this. This is step 1, setting up the proportion. Done. Step 2, solve by cross multiplying. So remember how to cross multiply? Look at the 2 diagonals. Which one do you know both the numbers? Not this one, because we don't know the W. It's the other one. This one we know both the numbers. So in order to get W, we have to multiply 2.5 times 125, and then we're going to divide by the number that's left over, right? We're going to divide by the 33. Pull out your calculator. You'll get the answer is 9.5 basically. It rounds to 9.5. Okay, now what does this mean? What did we just find out? We found out that when 125 centimeters of snow melts, it melts down to 9.5 centimeters of water. That is what we have found out. 9.5 centimeters of water. We've clearly given our answer. I've circled it to make it even clearer. Great job. Moving on. What we're going to do for all these, we're going to set up a proportion. Whoa, it's a terrible horizontal line. Elsa's car traveled 132 kilometers on 8 liters of gasoline. How many liters are needed to travel 320 kilometers? Look at, we've got kilometers, we've got liters. These are different units. This is a rate. All right, this is a rate. So the first comparison we have is that 132 kilometers requires 8 liters of gas. Now this time, since you have the units, you don't even really need to write over here. You could, but you could put distance, and you could put gas here if you want. What the heck, I'll put gas on the bottom here. Okay, so over here we have how many liters are needed to travel 320 kilometers. Are we putting that 320 on the top or the bottom? Well, look, kilometers on the top, kilometers right here. It must go right here, 320 kilometers. What goes on the bottom? Whichever letter you want. Since we're talking about gas, I'll put a G, a capital G. And we're ready to cross multiply. You cannot cross multiply this because of the G. You don't know the G, but you can cross multiply this. So in order to get G, you are going to do 8 times 320, and then you're going to divide by 132. Thank goodness for calculators, people. It ends up being 19.39 repeating, or it rounds to 19.4. I'll put 19.4. Now, what are we talking about again? Look on the bottom here. We were talking about gas, liters of gas. So it's 19.4 liters of gasoline. In order to go 320 kilometers, you need 19.4 liters of gasoline. Clearly stated my answer. I'm in good shape. Next, 45, so that's a number right there. 45 out of every 100 Canadians are overweight. If Canada has approximately 35 million people, so there's another number, how many of them are overweight? So we have our three numbers. There's always going to be three numbers and one missing. The first comparison we have is that 45 out of every 100. Okay, what do these numbers refer to here, the 45 and the 100? 100 are Canadians, right? For every 100 Canadians, 45 are what? 45 are overweight. The overweight actually goes with the 45. It's weird because they're so far apart. So these are the overweight people. Okay, if Canada has approximately 35 million people, so are those 35 million, is that the number of Canadians or is that the number of overweight Canadians? That's the number of Canadians, right? We're trying to find how many are overweight. Overweight's the one we don't know. This is our, I'll put an N. I don't want to put O because it'll look like a 0. So that's what we're trying to figure out, is the overweight people. We know the total here. It's 35 million is the total number of Canadians. And we're good to cross multiply. Can't do this because the N, we have to go this way, right? We're multiplying this times this. So in order to get N, we're going to multiply 45 times 35 million and then divide it by 100. If you want, just go 45 times 35 divided by 100 and then slap the word million on the end. Or if you want to actually put 35 million is 35 with 6 zeros after it. So it's up to you. And you end up with 15.75 million. What's that referring to? Remember, that's the number of overweight people in Canada. So there's 15.75 million overweight people in Canada. It's quite a few, isn't it? Overweight people in Canada. Okay, moving on. Okay, these last two questions, we're going to look at unit rate. Remember, unit rate is where the second number is equal to 1. So it says Tina travels 100 kilometers in 90 minutes. So we could write this as a rate, right? The rate would be 100 kilometers per 90 minutes. But again, that's a weird thing to say your speed is 100 kilometers in 90 minutes. We don't usually do it that way. We want this second number to be 1. So you could do it this way. You could say 100 kilometers in 90 minutes. That's our first fraction. Now we want a second fraction. Remember, it's a unit rate. What do we want this number to be down here? We want it to be 1. We want it to be in 1 minute. And then this would be your unknown up here. I'll put K for kilometers. And cross multiply. So K is equal to 100 times 1. Well, that's pretty easy. And then divided by 90. And that gives you 1.1. So what did we just figure out? We figured out that you go 1.1 kilometers in 1 minute. So you could write it as a rate again, as a unit rate. You would say 1.1 kilometers in 1 minute, or you could go 1.1 kilometers per minute. But let's just think about this for a second. This still sounds kind of weird. It's not wrong. You know, it's true. You're going 1.1 kilometers in a minute, and maybe that's useful. Maybe that's the unit rate you want. But usually when you give speed, you don't go kilometers per minute. You go kilometers per hour. So let's look back here again. Wouldn't it be nice actually if this wasn't in minutes, if it was in hours? How many hours is 90 minutes? Well, 1 hour is 60 minutes, and it's another half to give 90. So another way you could have written this unit rate is 100 kilometers in 1.5 hours, right? 90 minutes is 1.5 hours. This will actually give us a more useful unit rate because we'll set it up again, 100 kilometers, 1.5 hours we're going to put this time, not 90 minutes. We've switched the 90 minutes into 1.5 hours. Again, we want to know how far. We want the second number to be 1, but not 1 minute. We want it to be 1 hour. And this top number is what we don't know. I'll call it, I don't know, I'll call it n this time. So in order to get n, we cross multiply. We go 100 times 1, again, that's no problem, and divide by 1.5. So n is equal to 66.6 repeating, or it rounds up to 7, 66.7. And what was that? That was, we found this number here, which was kilometers. So you could say 66.7 kilometers per 1 hour, or most likely how you would write this is 66.7 kilometers per hour. I mean, that's totally the way we talk about speed, right? If someone tells you, oh, I was going so fast in my car yesterday, I was going 1.1 kilometers per minute, you'd be like, oh yeah, that sounds pretty fast, but I don't really, can't really comprehend that. But if someone tells me 66.7 kilometers an hour, I can really picture exactly what they're talking about. All right, last one. Stacy sells 12 books for $18. We got a rate here, right? Books, dollars, those are different. So 12 books, $18. That's our rate. But we want it to be a unit rate. We want the second number to be 1. Okay, so we could do this. We could say 12 books and $18 is our first fraction. And in the second fraction, since it's a unit rate, we want this second number down here to be, the denominator to be 1. We actually want it to be $1 down here. All right, let's call this B, and we'll cross multiply. So we cross multiply to get B. We go 12 times 1, and then we divide by 18. So B is equal to 0.666666. I'll just put 26. So what does that tell us? It's 0.66 books for every $1. Okay, again, that's kind of weird. It's not wrong. It's true. That's a unit rate. But if someone says, how expensive are the books? You don't usually say, oh, well, for $1 you can get 0.66 books. It's not the dollar we want to be unit rate. We want the number of books to be the unit rate. So actually, what would be smart to do in this one, instead of going number of books per dollar, write it as number of dollars per book. Just turn it around. Then write your first fraction, 18, 12. Your second one, we want this is 12 books. I'll write it up front. We want to know how much does one book cost, right? Isn't that really what we're interested in? We want to know how much one book costs. We're not interested in how many books you can get for $1. That's weird. We want to know how much does one book cost. So we're going to put the 1 here. We have the books on the bottom. This is what we don't know. I'll call D for dollars. And I cross multiply. So I've got 18 times 1. I divide it by 12. And if you do that, you get 1.5. 1.5. What are we talking about here? It's dollars. Oh, wait a minute. It's $1.5 or $1.50 per one book. Or again, how you'd probably write that is $1.50 per book. That's way easier to picture, right? I tell you it's $1.50 per book, and you're like, whoa, cheap book, that's awesome. I tell you for $1 you can get 0.66 books, and you're like, what are you talking about? Why would I give you $1 and you don't even give me a whole book? You only give me 2/3 of the book? That's just weird. All right, so it can be tricky with the unit rates to figure out which one you're dividing by which. All right, good luck, everyone.